This will be Advent of Code, day 11, starting in 3, 2, 1, go. Monkey in the middle. As you finally start making your way upriver, you realize your pack is much lighter than you remember. Just then, one of the items from your pack goes flying overhead. Monkeys are playing keep away with your missing things. To get your stuff back, you need to be able to predict where the monkeys will throw your items. And after some careful observation, you realize the monkeys operate based on how worried you are about each item. You take some notes, your puzzle input, on the items each monkey currently has, how worried you are about those items, and how the monkey makes decisions based on your worry level. Okay. For example. Okay. Starting items. Oops. Day 11 input. So this will crash, but that's fine. I just want my input file so I can start looking at that and parsing it. Okay. Module monkeys. Monkey. Type T equals num int items int list. Oh my god. Operation is old. How your worry level test shows how the monkey uses your worry level to decide where to throw. Oh my god. Monkeys take turns inspecting and throwing items. All right, so I just need to keep parsing this. Operation is module opt equals struct let's just do type T equals plus val plus of int times of int and a square. And then an operation is a opt operation. Test divisible by is an int if true monkey num, if false monkey num. let create parse stir. Oh yeah, that's why. String dot replace. Replace. Okay. Substir replace all. String dot substir replace all input pattern with and this needs to be something that won't appear. And then string dot split on list dot map list dot to array dot map f fun s monkey s monkey dot parse. Eight monkeys. Parse stir equals string dot split lines stir lines equals array dot of string or array of list in let num scan f lines 0 monkey d function ID in let starting items equals scan f lines 1 starting items fun items in num items operation test divisible by if true monkey num if false monkey num in let operation equals operation dot square let test divisible by equals 0. If true, monkey num false. Starting items, and then this is items dot string dot split items on list dot map f string dot strip list dot map f int dot of string. Let monkeys monkey list one. There we go. Let's look at our monkeys. Oh, it has an array. I think there's a way to not compile it and just do a what int of string on comma print s What is this printing at? 58 quotes. String dot strip. Again? End line. equals if true, false, throw to monkey. Test divisible by in. Test divisible by okay, 57. Oh. It just stops after the comma. I see. Okay, so what I really want is drop prefix string dot length starting items equals oh, and then these are all wrong, these line numbers. 0, 1, 2, 3, 4, 5. I want to see my monkeys. Great. 57 divisible by 11. Monkey 3, monkey 2, monkey 1 items 5, 8, 93 up to 65. Divisible by 7, 6, 7. Great. Now I just need to do the operation. String dot drop prefix oh, I can do this. Scan F 1, 2, and this is operation new equals old. Fun op arg operand. Match operand operand. Let's just add a double here. With times old, then this is operation dot square plus old operation dot double. Operation dot times int dot of string operand plus and then int. Assert false. And now we have it'll be times 13 plus 2 plus 6 square times 13 plus 2 plus 6 square plus 3 times 7 plus 4. Great. All working according to plan. All right, 22 minutes just to parse the input. Not great. How long would that have taken me in Ruby? It would have been faster. Okay. So now what do I do with it? The items, each monkey has how worried you are about those, how the monkey makes decisions based on your worry level. Okay, worry level. Test how your monkey uses your worry level to decide where to throw an item next. Okay, after each monkey inspects an item, but before it tests your worry level, your relief that the monkey's inspection didn't damage the item causes your worry level to be divided by 3 and rounded down. 11, 3. Great. Monkeys take turns inspecting and throwing items. On a single monkey's turn, it inspects and throws all of the items it is holding, one at a time, and in the order listed. Monkey 0 goes first, then monkey 1, and so on until each monkey has had one turn. Okay, so there's stack. Is there queue? There better be a queue. Great, perfect. I don't know why this website's so slow. I think my computer just might be slow. Okay, where? index container. I don't care about the folds. Yeah. Who are you? How do you know that I'm on a 2015 MacBook Pro? Okay, NQ and okay. Touche. Yeah, it was a little busy moving to New York, so I didn't stream for a while. I was just discussing with a friend about moving to, or about getting a new MacBook. Items. Q dot of list 1, 2, 3. Q dot DQ. Okay, perfect. Q dot of list. Okay. Oh my goodness. Two most active monkeys. Count the total number of times each monkey inspects items over 20 rounds. Okay. Items, mutable, items inspected. Then let's see here. Inspect. Next item. Those were levels. Thrown to monkey 3, worry level 500. Okay. Oh, is there a fun, like, iter? What I'm looking for. I want is I want to iterate over the queue, but use up everything. Is that not possible? So not the container functions. Map concatenate filter in place, create empty queue. Interesting. There's no like drain. I want like a method drain. So this will return a worry level and let's see, if t.items q.empty then none else, let item equals t dot items inspected plus 1 item equals q dot dq items in match q dot dq t dot items with none, then none, some item, then okay, some worry level, let worry level equals operation dot apply t dot operation to worry level in, let apply t old equals match t with plus x old plus x times x old times x double old times 2 square old times old okay, so that worry level equals that. Worry level equals worry level divided by 3 in, and then divisible by if worry level mod t dot test equals 0, then worry, some worry level t dot if true monkey num, else some worry level t dot if false monkey num. In some worry level test monkey. So now we need to do this 20 rounds. List range 0, 20. List.iter. So each time we will loop over all of the monkeys. Array.iter monkeys, monkey, fun monkey. While not q dot empty monkey dot items do done. Let has items. Let worry in worry level monkey dot inspect. Next item monkey in monkeys q dot enqueue. Items worry level. Empty is empty. Is empty. I want to count the total number of times each monkey inspects items. So I want to list dot top monkey business equals array dot map monkeys m dot items inspected array dot sort compare int dot compare sending array dot to list array dot take to list why isn't take list product. Thank you. Monkey business. Oh, items inspected. Items inspected equals 0. Sort. Oh. Items inspected. Business equals product list dot take. There we go. Has items. Oh. While monkey dot has items. One, 2, 1, 4, 5, 0. Woohoo! You're worried that you might not ever get your items back. So worried, in fact, that your relief that a monkey's inspection didn't damage an item no longer causes your worry level to be divided by 3. Unfortunately, that relief was all that was keeping your worry levels from reaching ridiculous levels. You'll need to find another way to keep your worry levels manageable. At this rate, you might be putting up with these monkeys for a very long time, possibly 10,000 rounds. Using these newer rules, you can still figure out the monkey business after 10,000 rounds. After 10,000 rounds, adjust worry. If divide by 3. Divide by 3. Okay. Part 2. $10,000. Divide by 3. True. False. Not the right, too low. You'll need to find another way to keep worry levels manageable. Print us monkeys. Oh, it does look like there were some overflows. Then relevel t test visible by. Two 8 2. Okay, there we go. That seems more reasonable. Too high. Too high. Too low. Oh, let's see. Hold. Oh, I can just take the product of all of the divisibles. Module reduce worry type T of type T equals divide 3 take mod of n of int. Let divisibility checks equals array product of array.map monkeys m.test divisible by. Reduce worry 3 reduce worry dot take mod reduce worry reduce worry, match, reduce worry with reduce worry dot divide 3. Reduce worry, take mod n. Let's go. Let run simulation. What is it? Run monkeys, itters, reduce strategy, reduce worry. In monkeys. Itters. In monkey business equals run monkeys. Monkeys 20 reduce worry in reduce worry. Reduce worry. Get out of here with your spam. Cool. All right. This problem, I did it in under an hour. Was a doozy, sort of. I guess I spent like 20 minutes parsing and then 40 minutes actually doing the problem. Cool. So this problem, this is our input. So first we need to parse it. So parse input. I'm gonna move this up. Whatever. So parse input. Well, one problem is we're breaking on empty lines, and String.split in OCaml doesn't have that functionality. You can't split on a string. You can only split on a character. And so I replace all the double lines with $signs, and then I split on the $sign character to get these chunks. And then I convert that to an array, and then I map over this to parse the monkeys. Parsing the monkeys, a monkey is a monkey has a number, which actually I don't end up using. It has a queue of items, has an operation that it does. It has a thing that it tests divisibility by, and then if it's true, it throws a monkey to a monkey, and if it's false, it throws to a monkey. So this isn't that exciting to parse it. I split up the lines. I get the monkey from here. I drop this prefix and then split on comma, strip all the strings, map of string over everything, and then create a queue out of them. The operation, I look at the operand and the operand and the actual operation. I had old times old. I didn't have old plus old, but I imagine that could have showed up, so I handle that. And I just have this operation thing that is one of these. It's either plus adding a value, times a value, double or square, and then you can apply it to an old value to get a new value. So parse the operations, I get the divisible by and the if true monkey num and if false monkey num. And then I also keep track of how many items it's inspected. So then simple to check if a monkey has any items, I just check if the queue is not empty. So that solves parsing the monkeys. And then I get these monkeys, and then the way this works is every monkey inspects all of its items at once. It looks at this is like a worry level, which is just a number. It updates that worry level with some value. It applies some operation to that worry value. In part 1, it then divides that worry level by 3, and then it applies this test based on the worry level and decides which monkey to throw it to. So to run my monkeys simulation, I run for a certain number of iterations, which is 20 for part 1, 10,000 for part 2. I loop over each round, I loop over each monkey. While that monkey has items, I inspect an item to get the worry level of that item and the destination monkey, and then I queue it in that monkey's items that it'll inspect. What does it take to inspect an item? This is up here. Increment the number of times that it's inspected an item. Get that item, apply the operation. Then for part 1, I reduce the worry level divided by 3. And then if the worry level mod the test divisible by 0, then we throw that to the if true monkey num, otherwise to the if false monkey num. And then we return that tuple. So then that runs all the turns. Then we want to calculate the monkey business, which is the product of looking at all the monkeys, count how many items they inspected, take the monkeys that inspected, the 2 monkeys that inspected the most items, and then take the product of how many items they inspected. So map over the monkeys, get their items inspected, sort that, descending order, convert it to a list, take the top 2 items, and then take the product of it. So that computes the monkey business. For part 2, we need to do this 10,000 times, and we're no longer gonna be doing this reduce worry thing, because it we're not gonna do the divide by 3 thing, and so the worry levels keep increasing. And we find in this very nebulous manner, we need to find another way to keep worry levels manageable. And they don't really explain anything beyond that. Wow, this is a lot of items inspected. Billions of items inspected. And it only takes like a second or 2 to run still. So when I just did this I just got rid of the divide by 3 and ran it, I got a answer, but it was incorrect. And then I printed out the worry levels. Interesting. How does it end up with the same thing over and over again? Probably why it broke. Print out the... Oh, those are just the same worry levels. Interesting. Print out all the items, and all the some of the worry levels are negative, so clearly we were wrapping around, and that was causing problems. So you need to figure out some way to fix that. So my first inclination was, well, the monkey is going to test this divisible by thing. So rather than dividing it by 3, I can just take the worry level mod the monkey's divisible check, and then it'll end up being the same thing. It'll still throw it to the same monkey. But that didn't work because the monkey will, with that change, will still throw it to the right monkey, but then afterwards, the worry level for the next monkey will be incorrect. So all of these operations are just plus and times, which are, when you take the mod of something, they commute. Yeah, they commute with mod. So like x plus y mod n equals x mod n plus y mod n mod n. So like, and same thing for times. So basically like n modulus distributes over plus n times. So if I look at these divisible checks, something interesting about them, they're all prime numbers: 11, 7, 13, 5, 3, 17, 2, 19. They're the first 8 prime numbers, right? 2, 3, 5, 7, 11, 13, 17, 19. Yeah, first 8 prime numbers. So I can just take the product of those, and then whenever I reduce the worry, I can take the mod of that product. And so that's what I do. So then when I have this little reduce worry thing, that is either a divide by 3 or a take mod. And so If it's a divide by 3, I divide it by 3. If it's take mod, I take the mod. And then that keeps the array levels manageable. And how long does this take? Wow, it's so fast. That's amazing. How does it do it so fast? Computers are so fast. Yeah. All right, that's day 11.